Okay, we're in lesson 13.3, and we're going to do something called the unit circle. And before that, we actually have a little bit of work to do. And so far you've looked at degrees. We've been looking at the circle from going from 0 to 360. Sometimes it goes a little bit farther around than that. There's also another measure that angles are recorded in, and it's something called radians. And here it defines a radian is a unit of angle measure based on the arc length. So when we're talking about degrees, so radians are based on an arc length, where degrees are based on the angle. So when we talk about a radian, we're talking about this area out here, the arc length. When we're talking about degrees, we're talking about the angle in here. Okay, so there is a little bit difference to them. A lot of times that angle measures are used they use degrees and radians, just kind of depending on the situation we're talking about. Okay? So here it shows 1 radian, and a radian, since we're talking about arc length, we're talking about the distance around a circle. And we're talking about the outside part, right? When we're talking about arc length. Well, if I go all the way around the circle, how far is that? When we're talking about the outside, what are we talking about? Okay, 360 if we're talking about degrees. But if I'm talking about the outer part of a circle, what do we call that? What? The circumference, okay? So we're basically talking about the circumference. Well, how do you find the circumference of a circle? C is equal to 2 pi r, okay? Well, what if r is 1? What do we get? Okay, then it's just 2 pi. Okay? Well, when we start talking about radians, we're going to be talking about using the unit circle. And the reason it's called the unit circle is because the radius is 1 unit. Okay? So when we talk about going all the way around a circle, we're talking about either that being 360 degrees if we're in degree mode, okay? Or we're talking about 2 pi radians if we're talking about radians. Okay? So all the way around the circle is 360 degrees or 2 pi radians, and halfway around the circle then is 180 degrees or pi radians. So take your calculator for a second, all right, and take 360 degrees and divide by 2 pi. Okay, and make sure you put that 2 pi in parentheses. Like I said, make sure the 2 pi is in parentheses. 360 divided by 2 pi. Okay, 57.3 degrees. So 1 radian, okay, is basically equivalent to 57 degrees. Okay, and that's pretty close to 1/6 the way around a circle. Okay? So here the first thing we're going to do with before we get into the unit circle is we're going to do conversions from radians to degrees and degrees to radians. Okay? So if we're going to convert from degrees to radians, we're going to multiply the degree measure by pi over 180. Okay? Because according to our numbers here, since pi is equal to 180 degrees, pi radians is 180 degrees, we can use conversions to change them. Just like 1 foot is 12 inches, right? If we want to convert to inches or feet, we can use a fraction to do that, a ratio. So if we're going to go from degrees to radians, we're going to multiply by pi over 180. If we're going to go from radians to degrees, we're going to multiply by 180 over pi. Now, when we write our answer in radians, we will always write our answer so it will look like this, like 3 pi over 2, something like that. Okay? So, and that's the way we'll read it. We won't read it as 3/2 pi. We'll say this is 3 pi over 2, and the pi always goes in the numerator with any number you have there. Okay? All right, so let's do some conversions here. So here they want us to convert this first one is in degrees. When they see that little circle, you know it's degrees. They want us then to convert this to radians. So that means we're going to take this and we're going to multiply by pi over 180 degrees. And if if you remember correctly, when you've done unit conversions before, we want to make sure that whatever's in the numerator, that same unit's in the denominator, right? So that they cancel, right? So here I have degrees in the numerator, so I want degrees in the denominator so that the degrees cancel out. And so when we're doing this, all we're going to do is we're going to write it as a fraction and then simplify the fraction. Going from degrees to radians, that's all we're going to be looking at. So this is negative 60 pi over 180. And then it's just a matter of reducing this fraction. How many times does 60 go in 180? 3 times. Okay. So that means that we have a 3 here and a 1 here. And so this answer is negative pi over 3. Right? We're not going to put the 1 there. Right? And that's how I read that. We'll say it's negative pi over 3. And when it's in radians, you don't have to write radians here. You can if you want. Okay? But that's just a given thing. With degrees, you do have to put the little circle. Radians, you don't have to write anything after that. If you want to write it in, you can. Okay? And then converting from radians to degrees then, since radians is our unit we're trying to get rid of, then that means I want radians in the denominator. So this would be 180 degrees over pi radians. So in this case, I put the degrees in the numerator and the radians in the denominator. And that way, then these radians will cancel out. And also then the pi's will cancel because I have pi in the numerator and pi in the denominator. So then we have 2/3 times 180. And so you can do this a couple different ways. You can say, okay, 3 goes in 180 60 times, right? And have 2 times 60. Or I can do 2 times 180 and divide that by 3. However you want to do it, you get 120 degrees. Okay. All right, so convert from degrees to radians, we multiply by pi over 180. To convert from radians to degrees, we multiply by 180 over pi here. So. All right, so we're going to learn about this thing called the unit circle. Now, it's in your book, as Derek already found out, and started copying it down. And you can do that, but I really want to go through the process of explaining it to you, because then you really can understand, okay, where do these numbers come from and why, instead of just writing them down randomly. Okay? So it's completely based on these 2 triangles, the 30, 60, 90 right triangle and 45, 45, 90 right triangle, which you learned about the other day. You were actually using the values for sine, cosine, and tangent for them. And on our unit circle, we are actually going to be using sine, cosine, and tangent. Now, cosine is always going to be, or I should say that we have coordinates. Okay, this is a coordinate plane here. We have our x-axis here, and we have the y-axis here. Okay, I've done better with these, but all right. So all of these parentheses here represent points on the coordinate plane, like the point 2, 3 or the point -5, 8. Okay, they all represent points, but all those points are related to the 2 triangles, 30, 60, 90, 45, 45, 90. So first of all, so we're going to have all of our points are going to be in this form. It's going to be cosine is our x value, sine is the y value, and on the outside will be tangent. So the sine or cosine is x, sine is y, and tangent is on the outside. And you'll notice that on the left side of the unit circle, the outside is on the left side of it, not the right. Okay? All right. So, but it's always, so cosine is x, sine is y, and tangent is on the outside. Now, this is called the unit circle, once again, because the radius of this circle is 1 unit. So we're going to do all of our degrees first, okay? And then we're going to cut it into radians, and then we're going to do all of our coordinates. So first of all, and I have put things up here a specific way for a purpose then. Okay? So first of all, we're just doing just degrees. Okay? And I'm going to use black for degrees, smaller. Okay, now on the x-axis here, how many degrees is that? 0. Okay, so this is 0 degrees. Okay, and if I go, now you're going to want to put your degrees around the inside of the circle here, okay? Because we're going to put radians around the outside edge of the inner part of the circle, right? So if we go up to here, straight up, how many degrees is that? 90. Okay, so this is 90 degrees. Okay. And if we go over here to the negative x-axis, that's 180. Okay, 180. And if we go down, we're at 270 degrees. Okay, and if we come back up, we're at 360. Okay. Now, the one thing about the circle is that it goes on forever. Okay, right? Circle never stops, does it? So I could keep going around counterclockwise many, many times, or I could go clockwise, and if I went clockwise, what would the difference be? Yeah, the angles would be negative. Okay, that was something you learned the other day. If we go clockwise, the angles are negative. Okay, now, if you notice on my circle here that I have, in between those, I have light colored lines and I have more lines that are bold, right? Okay. Now notice the light colored lines. Okay? The light colored ones would be like here and here, and it takes me up to that one, and here and here and there. Okay? So I've taken 180 degrees and I've divided it into how many pieces? Let me make them bigger here. Hold on. That one wasn't very good. All right, so how many parts do I have there? There's 6, right? There's 1, 2, disregard the black ones, okay, the dark ones there. So there's 1, 2, 3, 4, 5, 6 pieces, right? Okay, so if I take 180 and I divide it by 6, what do I get? 30, okay? So that means each one of those groups is 30 degrees, right? Okay, so then that means then that this is 30 degrees here. And if I go another 30 degrees, I'm where? 60 degrees. Okay. If I go 30 more, I'm at 90 then, aren't I? Okay. 90 plus 30 is 120. I add 30 to 120 and I get 150. 150 plus 30 is 180. And then that continues all the rest of the way around the circle. So then in the bottom half of it, I've done the same thing. So I just keep adding 30 degrees. So basically, I took this circle and I divided it up into 6, didn't I? Okay? All right. Divided up into 30-degree parts. Okay? And with those 30-degree parts, then, I can write it in there. Okay? All right. Now, so there's our 30, 60, 90 degree angles, aren't they? Okay. All right, so now let's look at it. Let's change it. Let's use a different color here. And I now have these bold lines here. And with those orange lines then, what did I divide this circle into? Or the top half of it? Into fourths. Okay? So if I divide into fourths, how much is each quarter then? 45 degrees. Okay? So now we're at, so each of these is 45. Well, and 45 plus 45 is 90. Plus 45 is 135. Plus 45 is 180. And so on. So then we get 225. And then 315 is our one in the other spot. Okay. Now, we're actually, we're going to do radians also. All right? And so we're going to do the radians next. And so I can leave that stuff back up there. All right? So I'm going to do a little, oh, I can't do what I want to do. Okay. All right, I'm going to use them then. Okay. All right, so let's talk about radians now. There's our degrees. Let's talk about radians. And one other thing I want to remind you of also is every once in a while I will talk about quadrants. Which quadrant is this one here? Okay, this is the first quadrant. Okay. All right, we'll be using quadrants as we talk about them. Okay. Number 2, second quadrant is the upper left. Third quadrant, bottom right. And the bottom left, and the fourth quadrant's in the bottom right. Okay? And we'll talk about quadrants at different times. So, all right? Now, we're going to use those same, I'm going to use those same parts there to do, and talk about radians for a moment. Now, so radians, I'm still at 0 here on the positive x-axis. If I go halfway around, where am I at? How many radians? That is pi radians. Because all the way around is how far? 2 pi. If all the way around is 2 pi, then halfway around would be 1 pi. Okay? So then how would the spot that's at 90 degrees, okay, well, how would that compare then? Okay, how much, Ridge? A half. Or we're going to call, we call that pi over 2. Okay, we don't say 1/2, we say pi over 2. Okay. So we have 0. We go to the positive y-axis, I have pi over 2, so that's 1/2, right? So this would be 1, correct? So down here at 270, what would that be? Okay. That would be 1/2 or 3 pi over 2. Okay. So we're working with, think about fractions for a moment. Okay, I've divided into halves, so we have 1/2, 2 halves, 3 halves, and then 4 halves. Okay, 4 over 2 is 2. Okay, now, all right, let's go back to our orange lines I've drawn up here. Now, you told me before I divided that into four pieces, right? Okay, so if I take if I take pi and divide it into 4 pieces, how much is each piece then? Pi over 4. It's 1/4 of pi, right? So it would be pi over 4. So 45 degrees is the same as pi over 4. Okay? Because that's 1/4 of pi. Then at pi over 2, it's 2/4, which is 1/2. Okay? So what we're going to be doing here is we're working with fractions, and we're just going to be reducing fractions. So we've got 1/4, 2/4, and this would be 3/4, so 3 pi over 4. At pi, it's 4/4. Well, what's 4 over 4? 1. Okay, so there's our 4/4. So if we go to 225, that would be 5 pi over 4. 3 pi over 2 is the same as 6 pi over 4, which reduces to 3/2. And then at 315, it would be 7 pi over 4. And then 2 pi would be 8 pi over 4. All right. All right, so let me get rid of our orange ones now and go back to our purple. And we might be able to do that. I hear Gallery talking about it right now. And so let's talk about the other ones then. Okay, the other ones, when I did the 30, 60, 120, and all that, what did we divide the top half in then? How many pieces? 6 pieces, right? Okay, so how much is each piece if I divide it into 6 pieces? 1/6. So at 30 degrees then, it is pi over 6. Because that's 1/6. Then at 60 degrees, it would be 2/6, and 2/6 is, 1/3, so this is pi over 3. And this is why, Derek, I didn't want you to just write it down. Okay? All right? So we have 1/6, 2/6, 3 over 6 is 1/2. Then we have 4 over 6, and 4 over 6 is 2/3, so 2 pi over 3. $150 would then be 5/6. And then pi would be 6/6, because 6 over 6 is 1. So then we just keep counting. 7, 8, 9, 10, and 11. So this unit circle is just fractions that we're simplifying when we're talking about radians. Okay? With degrees, we break it up into a certain number of parts. We could think of each 360 divided by 12 and get our 30 degrees, or 360 divided by 8 to get 45 degrees. Okay? But with radians, it's much easier to say, okay, there's fractions here, parts of circles or parts of a whole, and using them. All right? Okay, so there's our degrees and radians. Okay? Now you're going to have to memorize this. Okay? And that's the reason why I went through that process with you with the degrees and the radians, is so that you understand where everything came from. So it should, if you can divide it into 6, the top half into 6 or 4ths, you can fill in everything. All right. Now, we said this is a unit circle. That means that the radius is 1. So if the radius is 1, what is the coordinate of this point right here at 0 degrees? Okay. Right here, what's the coordinate of this point right here? 1, 0. So this is 1, this is 0. I went over 1 unit and I went up 0. Which means that cosine is x and sine is y. And most of what we do with the trig functions, that's always the case. And if you ever get them so that cosine is y and sine is x, you made a mistake. Okay? All right. So if we go to 90 degrees, and we'll work with I'll work mostly with degrees instead of radians here then. And then how about at 90 degrees? Okay. At 90 degrees, it's 0 and 1. I go over 0, I go up 1. Okay? So all of the on the axis, it's just coordinates. So at pi, or 180 degrees, what's the coordinate of that point? Okay? We went over -1 and we went up 0. So we're going to do sine and cosine first, and then we'll come back and do tangent when we're all done with them. Okay? And then we have 0 and -1 at 270 degrees. Yeah, we're going to do the sine and cosine and then come back. Okay. Now, you'll notice then that we have I have a triangle right here to find the coordinates of that point. Okay. Well, what size triangle do I have there? I have a 30, 60, 90 right triangle there, where this angle right here is 30 degrees. So I want to find the coordinates of a 30-degree right triangle. So I want to know what's the adjacent side, right? This is the adjacent. And what is the opposite? The adjacent is x, the opposite is y. So we need to find cosine and sine for a 30-degree angle, okay? Well, cosine is adjacent over hypotenuse, right? So square root of 3 over 2. Sine is opposite over hypotenuse, so 1/2. So we have square root of 3 over 2 for x and 1/2 for y. So square root of 3 over 2 for cosine, 1/2 for sine. Now, when we go to 60 degrees, what happens to those numbers? They switch, don't they? Okay? Because I've just switched where the 30-degree and where the 60-degree angle are. So the opposite is now square root of 3 and the adjacent is 1. So that means when I go to the 60 degrees, I just take the 30-degree numbers and switch them for sine and cosine. Okay, so get 45 then. And I want you to think about something. Is square root of 3 over 2 bigger or is 1/2 bigger? Square root of 3 over 2 is bigger, okay? All right, so I've gone farther over than I went up. Okay, you got that? I go farther over than I went up here, but when I do the other triangle, the 60-degree one, I go more up than I go over. Okay, so I kind of keep them in my head straight as far as which one goes where. Okay, 45 degree. Okay, sine and cosine. Oh, they're the same, aren't they? Okay, so they're equal to 1 over the square root of 2, but what does that simplify to be? Square root of 2 over 2. So for the 45 degree, they are the same. Square root of 2 over 2. Cosine and sine. Okay. All right, now, okay, these all work with x and y. Okay, so in the first quadrant, both x and y are positive, aren't they? Okay. But what happens when I go to the second quadrant? Okay. X is negative and y is positive, right? Okay, so let's go to the second quadrant then. Remember that conversation about reference angles? We learned about reference angles, right? Okay, so let's go back to our 30-degree angle here we were working with. Okay, and we're going to work with this one right now. Okay, so what angle in the second quadrant has a reference angle of 30 degrees? Okay, 150 does, okay, because it's 30 degrees from the x-axis. Okay, so that means then that this triangle here is exactly the same as our 30-degree angle here, right? The triangle there. So this angle here, this red angle, is the same as that red angle over there, which means it goes just as far to the left as it goes up, doesn't it? The only difference is that if I'm in the second quadrant, x is what? Negative. So this is negative square root of 3 over 2, and this is positive 1/2. All right. So then that means then that the 45-degree angle over here would be the same as 135. We just have x is negative, y is positive. And same with 120 and 60. Because you know what we just did? We just did a reflection. Okay? All this is a reflection over the line, over the y-axis. Because if I take all of this part here, and I flip it over here, 30 goes with 150, 45 with 135, 60 with 120. Okay? So I basically just did a horizontal reflection. Okay? Now, if we go to the third quadrant, what are x and y in the third quadrant? Okay? They're both negative. So these are both going to be negative in the third quadrant. Okay? So all I need to know is the correct reference angle. Okay? So that means I'm just going to take the top half of my circle here, and I'm going to fold it down onto the bottom half. Okay? So where's my 30-degree reference angle at? For in the third quadrant, where's the 30-degree reference angle at? 210. So my numbers I have at 30, I'm going to use them at 210, except they're both going to be negative. Okay? Because 210 has the same 30-degree reference angle. And so with that 30-degree reference angle, that means that these numbers here are the same. I went the same distance to the left, the same distance down as I did with our 30-degree angle. 225 would match. Okay, 45. Okay, because that's 45 degrees is my reference angle there. So we have negative, Yep. So negative square root of 2 over 2 and negative square root of 2 over 2. And then you know what? Once again, these two here with the 30 and the 60, they just switch. In the fourth quadrant then, x is positive, y is negative. Use our same reference angle. So where's our 30-degree reference angle in the fourth quadrant? Okay, it's 330. It's here. It's there. So in the fourth quadrant at 330 is, square root of 3 over 2, negative 1/2. Square root of 2 over 2, negative square root of 2 over 2. 1/2, negative square root of 3 over 2. Okay. And there's cosine and sine. And always remember that if I go farther over than I go up or down, then that number's got to be the square root of 3 over 2. Okay, is the longer side, and 1/2 is the shorter side. Okay. All right. Now let's talk about tangent then. We'll do tangent in green. Okay. Tangent. Now tangent is equal to sine over cosine, or it's equal to y over x. Because if you'll notice, tangent was opposite over adjacent, right? Okay. So if I go opposite over adjacent, which one's always the opposite side on our triangle? Opposite is always the y coordinate. The adjacent is always the x coordinate. Okay. So let's work with it at 0, 90, 180, and 270 first. So if I do opposite over adjacent, I get 0 over 1, which is what? 0. So tangent is 0 there. If I go to 90 degrees, we have 1 divided by 0. And that's undefined. You can't divide by 0, so it's undefined. So we're just going to put UND for undefined. Okay. What about at 180? 0 again. 0 divided by -1 is 0. And then 270, it's undefined again. Okay. All right. Now, I can do y over x here also in the first quadrant to find those numbers. Those are a little bit more difficult to work with. Okay? They're really not, but they are to a certain extent. So let's go back to our triangles. Okay? 30-degree triangle, or a 30-degree angle. Okay? Tangent is opposite over adjacent. So we get tangent of 30 is 1 over the square root of 3, right? So tangent of 30, well, what's that equal to? Okay, that's the square root of 3 over 3. Okay, you guys see that? Okay, multiply numerator and denominator by square root of 3. Okay. So tangent at 30 is square root of 3 over 3. Well, at 45, what's 1 divided by 1? 1. Okay, so at 45, it's 1. And at 60, the same thing happens, right? We switch the 1 and the square root of 3, and so we get square root of 3. All right. All right. All these numbers for tangent are what sign? Positive. Okay, so in the first quadrant, we have all 3 of them are positive. Okay. All right, let's go to the second quadrant. If I have a positive divided by a negative, what do we get? Negative. Okay, so tangent in the second quadrant is negative. So we're going to use those same reference angles to get over here. So square root of 3, 120, negative square root of 3. 45, negative 1. 150, negative square root of 3 over 3. Okay, with our reference angles. In the third quadrant, what happens when I divide 2 negative numbers? You get a positive. So tangent is going to be positive in the third quadrant. Now, here's the thing, okay? Whenever anybody makes a mistake when they're doing this, okay, it's usually in the third quadrant. I'm not sure why, but it's always the third quadrant. Because what happens is they want to take these numbers and just transfer them here down to here instead of actually reflecting them down, okay? Which means that 7 pi over 6 is closer to 5 pi over 6, right? Okay, those are the same. So this is positive square root of 3 over 3 here. Positive 1. Positive square root of 3. They just don't want to reflect down correctly. All right? And then if I have a negative divided by a positive, we get a negative. So the fourth quadrant, they're negative. The nice thing about what we just did is you learn tangents, okay, with it. Where in the book, they give you the unit circle, but they don't give you tangents. And tangent is just as valuable as sine and cosine. The reason they probably don't give you tangent is because they figure, okay, you can take y divided by x and find it. Okay. Well, we're going to use it now. Here we go. Now, this is really easy now, okay? It's going to be really easy for you, okay? They want us to find the cosine of 225. All right, so find 225 degrees on your unit circle. Yes, sir. No. Okay, so where's 225 at? 225 is down in the third quadrant, right? That's why we're going to talk about quadrants. It's in the third quadrant. Now, when we're talking about cosine, are we talking about x or y? X, okay? So x at 225 degrees is negative square root of 2 over 2. So my answer here is negative square root of 2 over 2. Okay? Okay. Tangent, 5 pi over 6. Where's 5 pi over 6 at? Which quadrant? Okay. And let's see, 5 pi over 6, is that less than 1 or greater than 1? I mean, the fraction, 5, 6. Is 5, 6 less than 1 or greater than 1? Okay. It's less than 1, okay, because 6 over 6 would be 1. Okay. It's less than 1, so that means it's got to be before pi. So that means it's either got to be in the first or second quadrant. Okay. So we go to 5 pi over 6. Oh, that one doesn't work. And we find tangent, and where's tangent at on our unit circle? Okay, the thing in green, which is on the outside then, and so that's negative square root of 3 over 3. Okay. When it asks you to use reference angles, you don't need to use reference angles, you just need to find it on unit circle. But here's how you must, okay, you heard that word, right? Here's how you must write your answer then. Can you read it off my back? Okay. So you're going to have to say sine of 330 equals, cosine of 330 equals, tangent of 330 equals. All right, you've got to write it like that. So then sine is negative 1/2, cosine square root of 3 over 2, and tangent is negative square root of 3 over 3. Okay? The only thing is that just the way you write your answer for me when you do these with reference angles. Okay? So your homework